Haven't. See, no one's even asked me for them. So, all right, let's start idle. Everybody should know what idle is. We're going to talk about recursion. We have a clue what recursion is.
I can Google it.
Okay, recursion is calling yourself. It's a you know what a function is now? Yes. Well, remember how we would call a function to do something. But what if you call a function to do something and that same function calls itself to do it over? We're going to learn how to do this, okay?
Okay.
So I'm going to make a new file. You will need this code to, well, okay. This code will help you do the homework assignment, okay? I'm going to name this thing, what's the date? The 11th. Okay, and I've been saving them on my desktop, and I've been saving them in this folder. And I'm calling them like this. So it's going to be October 11 in class. Okay. Now, I'm going to define a function. Okay. And it's going to be called Happy Birthday, but spelled that way. Okay. Now I'm going to, inside there, I'm going to print Happy Birthday. Okay. So far so good. Down here I'm going to call Happy Birthday. I'll just put a 5 in it for now. Nothing special yet. Okay. So far so good. Everybody with me? Now we'll move this over so Miss Sarah can see the screen. Does that help? Alright. So basically this printed out Happy Birthday. I just passed it a 5, although I did nothing with the 5. I could do something with the 5. I could go over there and just put X. Now it'll actually do something with the 5. Okay? So far so good? Everybody with me? Everybody? Yes? Every person. Okay. Well, this is not recursion. This is literally just a function to do something. But what if I had this function call itself? So after this print line, I'm going to call itself, but I want to pass it a lower number. Okay? So what's going to happen is I'm going to call Happy Birthday passing it a 5. It's going to receive a 5. It's going to print out Happy Birthday 5. Then it's going to call itself passing it what?
X minus 1.
5 minus 1, which would be 4. Then if we do this.
Oh my god.
Yeah.
I have seen the Matrix.
Okay. This is recursion. This is incorrect recursion, but it's recursion.
So it keeps subtracting the 1.
What it did was it called it with a 5, then it called it with a 4, then with a 3, then a 2, then a 1, then a 0, then a negative 1, and it kept going. So it kept calling itself. Okay? So imagine your computer, it branched off and called this function. Then that function branched off and called itself. Then that function branched off and called itself again. So it literally was getting deeper and deeper into the rabbit hole of functions running here. You understand? Then when it crashed, it basically says, I'm too deep, I can't go no farther. Okay? And we could actually change how deep it can go, but that's fine. So I only want to print Happy Birthday until I get down to 0. How can I do that? Anybody? What do you think? So obviously we can go 5, 4, 3, 2, 1. Then it continues. But I'm going to stop at that point. Well, Nathan came to see me today and we talked about the the return. Return can be used to get you out of something. Okay? Whenever you write recursion, you have to give it a way to get out. Okay? And a return is a good way to do that. You can say, hey, when a certain condition meets, return. In other words, stop. Okay? So if I wanted to continue as long as x is above a certain number, could I write something like that? What kind of decision or thing would I use?
Can you use a while loop?
Yes, but we're not going to.
Just do like return x equals 0.
Yeah, but we still need something else.
Could you do an in range, like a 4 in range?
I could do it for, okay. We could, but the difference between recursion and a loop is recalling itself is the loop. Okay? If you just had a for loop, it's not calling itself over and over and over again. Okay? It's different. Because the loop loops through something 5 times or 10 times or whatever times. What we want to do is just call ourself those times, but stop calling ourself. What type of structure could I use to check a value? An if statement, exactly. So how about if? So what might I want to check?
X is greater than 0.
Okay. So what if I want to? Okay, I want this if statement.
X equals 0.
Okay. So if x is equal to 0, then I want to return. See what I'm doing here? So I'm going to keep calling myself, but if x is equal to 0, we're out of here. So now let's see what we get.
Hey.
So what happened was we called passing in a 5. It printed happy birthday 5. First of all, I checked. Is x greater than? Yes. It's not equal to, it's not equal to 0 at this point. So then it calls itself passing in a 4. So it's a function now inside of a function passing in a 4. Is 4 greater than 0? No. So it says, okay, fine. Print out happy birthday 4. Then that function calls another function. It's called itself again, but this time passing it 4 minus 1, which is 3. So you see it keeps getting deeper and deeper. It's like a loop, but it's not a loop. It's actually much more efficient than a loop. Okay? But it's very tricky to write that part. I mean, because all we think of is loops. Yeah, we're going to keep doing this. But, so you see how this is working? Kind of understand that? Okay. So pretty simple there. And if I wanted to go more, I could literally just go over here and do like 50. And now it's going to print out happy birthday 50 times. Well, it's going to start at 50. Should have started at 50, did it? Okay. Very easy to do. Okay? All right. So, no problems there? Okay. That's recursion. Now let's do another one. Let's make another method called summation. We're going to use n in this case. What's the word summation mean? Anybody?
Like addition.
Like addition. We're adding something up. Okay? So down here, actually I want to move this down as well. I just like to keep mine in order. So I'm going to comment that out because I wanted to keep it, but I just don't want to use it right now. I want to do print summation. Okay. Now, I'm going to pass it a 5. So now we have a method here called summation that's going to receive a 5. Now, what I want summation to do is I want to keep adding up the numbers. So I want to add up 5 plus 4 plus 3 plus 2 plus 1. Okay? How could we possibly do this, you think? It's like a factorial, but we're not going to use factorial. We're kind of going to write our own factorial is what we're going to do. So, if I call summation passing it a 5, I want summation to call itself passing it a 4. But not really just a 4. It'll be the 5 plus the 4. See what I mean? Any idea? What do y'all think?
N plus 1.
N plus will actually be n plus the method or the function minus 1. Because we want to take the 5 and add the 4 to it. But we want to do it in recursive format rather than just a loop. So what we can do is, so what if I did this time instead of what if we use the return statement? This is not the total answer yet. Okay. So what would that do for me? So I call it summation. I call it passing it a 5. Okay? It receives a 5. It receives a 5 right here. Then that method or function returns a 5 plus calling itself with a 4. So it's returning a call to itself. See, Nathan came and asked me about this whole return thing. Return can be used really for two things. It can be used to get out of something. In this case, we're getting out of the happy birthday function. But it can also be used to return a value. So in this case, this is going to return n plus the results of the function. Then it's going to print it. Let's see what this does. I really don't know. I've never tried this. Oh, it sure didn't like it. What's it tell me is wrong?
Oh, is it because when you get to the end, it's going to be 0 minus 1 or something?
Hold on. Let me change my screen so I can see this. Hold on. I want my screen to be just 20. Apply and OK. Maximum recursion depth found. Wow, it already gone 900 times? That was quick. Okay. What it did was, we didn't, okay, remember on Happy Birthday we didn't give it a way to quit? We didn't give this one a way to quit yet either. So what it did is it called itself passing it the original 5 plus itself with a 4. Then it called it with that result plus a 3, that result plus a 2, that result. So it kept going forever. We never told it to quit. Now, how could we can actually see what's happening. Let's do that. Let's just do print. I just want to see what it's doing. I want to see what number is being passed each time. Okay? We're not going to leave that in there. So you can see it's passing a lower number each time. So did you all get it like that? Did it do that?
So you can just do the same thing if n equals 0.
We could do that. Let's try that. Okay? So if n you want to do equals 0, you want to return this statement right here? I don't know if that'll actually even compile. Oh, it actually did. It says none. We're close. But we need something. I want that to be at that same level. Okay? Well, what we want to do is, so when we reach 0, what do we want to do? Do we just want to return? Let's try just return. It probably won't like it.
But won't that return something else?
Right.
Okay.
Yeah. See, the difference between this one and the one at the top is this one's just getting out of Happy Birthday because we're actually doing something inside of Happy Birthday. This one we don't want to just return. What we want to return is 0. Okay. Because what we're doing is we're calling itself passing in a lower number. Then each time it calls itself, it's passing a lower and a lower number. When it finally reaches 0, then we want to back out all the way and add all these numbers up. Okay? So what we need here is else. Then we want this return statement. We're going to walk through this, see what this one does. Okay? Let's see what this is actually doing. So I'm going to write this down here. This is not part of the code. Don't write this. I'm just going to keep track. So we called summation passing in a 5. Okay? Don't write this. This is not the code. So it received a 5 right here. Okay? Then that returned. So that returned 5 plus summation 4. Again, this is not code. This is just my notes. Okay? And that returned what at this point? So we did 5 plus summation 4, which returned, crap, because it's a 4 plus summation 3. And that returned, because we passed it a 3, So now it returns 3 plus summation 2. And that returned 2 plus summation, again, this is not code, I'm just making notes here. Summation 1. And that returned 1 plus summation 0, which then returned to 0. So this number here returned to 0. Got that? So then it was 1 plus 0 is 1. So this was a 1. So this ends up being a 1. So 2 plus 1 is what? 3. So then this here returned to 3. So 3 plus 3 is what? 6. So this returned to 6. So then 4 plus 6 is 10. So then this here returned to 10. 5 plus 10 is 15. And that's the answer we got. See how that worked? It kept calling itself, passing it a less value every time. It's weird, and I tell you, until you start playing with this, it's crazy. So if we run it again, that was just my notes. That's nothing there. It did a 15, so which was perfect. Now, what we could do in here is if we wanted to see what it's actually doing, we could maybe print out n, just so we can see what number is being passed or something. See, it passed a 5, 4, 3, 2, 1. So it did count down each time, which was correct. So, and recursion's tough. And honestly, in the real world, I've never written recursion in an actual program. Because it's so hard to get it right. But once you get it right, it's like, wow, that saves so much time. Okay? I'm writing some code downstairs to generate assignments for my forensics class. I'm on the third rendition of this one function already. Just this one function, because I keep making a little better and a little better, and I'll get it done here one of these days. But the point is, recursion's hard. Okay. So everybody got that to work. We got summation to work. We got happy birthday to work. So you kind of get an idea at this point what recursion is. It's a function calling a function, calling a function. It could call itself, and it's not calling a different function. It's calling itself. But the important part is whenever you do this, you have to have some way to get out. You have to give it a doorway here, something to get out of here. So far, so good? Okay.
So could you do n plus 1 and then if n is equal to, like greater than or equal to like 100?
Actually, this one here, you mean on summation?
Yeah.
You could. You could do greater than or equal to 100. Oh, you mean change this here?
Yeah.
Let's try it. Let's see what we get. We should get a big number. Wait a minute. That's not very big. So we passed it a 5.
You did less than.
You did less than.
Oh, that's why. Wow, that was a huge number. Wow. Yes, it's actually very efficient. Yes, ma'am.
I'm just having like an error on mine. I keep trying to fix it, but it won't.
Is it what I had a minute ago?
No, it's like the below else, the return part keeps.
Okay, let me get back to what I had. What did I have a minute ago?
0.
I had that, and I had a minus, correct?
Yeah.
What do you keep getting on yours?
Like below else, I'll just be like I'll try and I just went backspace and I'll just did that, but then there'll be like a space right here.
Run that down. First of all, comment that out. That's not really code. That's an error.
This one?
Yeah, put a pound sign.
But whenever I go back like that, then it'll like highlight the RE. Is there like a preference?
Oh, get rid of that colon up there. Why is there a colon there? See that colon after the 0? Now you're gonna end the other guy.
Change the.
You can try to run it, probably. I actually ran, but yes. Yep, that's what it was with that colon. Yeah, it's kind of important don't have a colon here because it'll cause an error. All right, So there's that one. That's the easy part. All right, now we're going to draw a tree. Yes. Make a new file. Actually, you know what? We can do it in the same file. That way you can. I want you all to submit this to me. I'm just going to comment out that so it actually does nothing. Okay. So if I run this now, it's going to do nothing. I just didn't delete my code. The reason is I'm going to provide this code to you. Okay. So there's that. So what I'm going to do now is down below we're going to make a new. Let's import a turtle. I know you guys like turtles. Okay, let's make sure we actually get a turtle. Sweet, we got a turtle. He's not doing a heck of a lot. All I did was import a turtle. Let me bring it up a little bit so y'all can see him. Making seeing the code's near the top of my screen here. Now, I want you to define a function here called branch. Trees have branches, don't they? Okay. Just checking. Now, in this case, I want to give it a way to get out. If n is equal to 20, we're going to return and be done with it. Now, down here, we're gonna modify that in a second. Down here, I'm going to tell it turtle.left.
So if n is less than 20?
Yeah, if n is less than 20. Yeah, type exactly what. Oh, did I say equals? Sorry, I meant less. Sorry about that. Okay, just write what I'm writing for the moment. Everybody kind of with me? Let's see what this thing actually does. Turn left. We didn't do anything. Okay? Not really cool at this point. All right. So what I told it was, we told him to take a left, 90 degrees. So the turtle was pointing over and he turned up. Okay? Set its speed to 0. Then I said call branch passing at 100. So branch received 100 right here. And it said if n is less than 20, return. And that's all it had, so it returned anyway. Okay? But now, what I want you to do, I want you to tell your turtle to go forward. Let's go forward. Let's go forward and n. Okay? So let's see what he does now. So my turtle should turn left and go forward 100. Y'all see that?
Yeah.
Everybody got that? Okay. Nothing fancy yet. But then I want our turtle to go left 300. So if I'm pointing up, in other words, north, where's 300? Anybody know? So basically looking at, y'all know it, how many degrees are in a circle?
360.
360. So we're almost going all the way around. Y'all agree with that?
Yeah.
Okay.
Can you just go right 60?
Not really. We could, but we don't want to. You'll see why in a minute. So basically my turtle's pointing to the right, kind of like, you know,
At an angle.
on an angle. Okay? There's something, actually I'm going to show you about 60 degrees. No, it's not 60 degrees. I'm going to just show you a picture, and this might be a decent picture to show you. You ever heard of a binary tree?
No.
Well, you'll learn about it in a course you'll probably never take called data structures, where basically it has a bunch of branches. And you can mathematically go down through this tree and sort things very easily, search things very easily. And it's actually the way the Macintosh file system works.
I thought we were building one.
See, when Windows does something, it kind of... Windows keeps an index of where your files are stored on the computer, okay? And whenever you want to access something, it reads the index and goes there and gets it. Macintosh, whenever you add a file, it actually reorganizes the files into a tree-like structure using inodes so they can actually get to them very quickly. It's just amazing. So that's kind of what we're doing with this. Okay. I know you've never taken data structure, so you're like, what did he just say? Well, that's fine. Don't worry about it. Okay. So we turn to left 300. Now I want to branch. N minus 20. Okay. So far, we turned left. We went up for 100. We turned all but 60. Or 3. We turned 300. Okay. Then we called branch again. So without running it, what do you think it's doing at this point? Okay, don't cheat and run it. So basically we turned until we were pointing to at an angle. Then we call branch passing at what? What's n at this point? 100.
80.
So now we're passing 80. So it receives 80. 80 is still greater than 20. So it's going to go forward how far? 80. Turn right again. So now it's going to be pointing that way. Okay? Then it's going to pass at 80 minus 20. 60. So now it's passing 60 up here. Still greater than 20. So we go forward 60. We're going that way. Then we turn left again. So now we're kind of looking down there. Okay? Let's see what this does. See that? So we're kind of making whatever the hell I want to call it. It's a branch, okay? It's a branch of a tree. Hence, this is called a tree. Y'all get something like that?
Yeah.
Okay. Oh, okay. Let me get my code up here. All right. Come on, Sarah. What are you breaking this time?
Well, it's doing the same thing, but I don't have any like extra colon.
It's saying return outside function.
Oh,
Oh,
what?
what's that big I in the F for?
What's the color I
Oh,
like?
I see.
Pale violet red.
Run it again.
What's the real? Is it pale violet red or red? It's pale violet. It seems for pale.
Oh, wait a minute. Where's your branch?
What's the color of the
Where's your branch method?
for the PowerPoint? I didn't see that.
Yeah, you need that in there. It's kind of important.
Pale violet red.
Yeah, make sure you put that there. Then all this should be indented underneath the branch. So let me let everybody got it to kind of do a.
A curvy?
So if you think about it, if we keep going, sooner or later it got to the point where n was less than 20, so it stopped curving in on itself. Okay? And that's how we got out. So far, so good? Okay? See if Summer gets there. Need a parenthesis there. Perfect. All right. So let's continue on. So now I'm going to just put a little space so I can keep these separated. So now I'm going to say turtle.write 600. I'll let Howard calculate what the number would be if I didn't do 600. Branch n minus 20. Okay, make sure I did it right. Hold on. We got the left, then we got the right. Okay. So now when I run it, that's not the right one. Hold on, I got something wrong.
Caitlin, what did you do? I like yours.
Okay, we went forward. I'm missing one. Left 300, branch 20,
Caitlin looks cool.
right 600. Hers might be right.
It's not.
Wait,
I love it.
something's wrong. What do I do wrong? Okay, I missed something. Let me see what yours does. Yours might be the right thing.
Caitlin, yours is so cool.
Let me see it. Wow. I have no idea what that is. Okay, hold on. I gotta find out what I typed wrong. Hold on. We move forward. We got that one. Then we got a left 300. We call branch. We got that one.
Oh, I broke it.
Then we go right 600. Call branch minus 20. Okay, let's finish writing. Then we'll see. I got to find out what I did wrong. Okay, I'm going to move my code up again if I can somehow. Okay. So then we're going to do left 300 branch and minus 20. Okay. All right, we're getting close.
Whoa, what? Wait,
See what I get.
what did you do that I did?
There we go. That was right. Okay, I just had to.
What is mine?
All right, you got to make sure you got all of them in there, because if they're in wrong, it'll mess it up.
Oh, yeah. Wait, did we get rid of the stuff at the bottom?
No, it's still there. I just moved it down.
Okay.
It's still there. I just did this in my code to go
What
to the
does
top.
the T dot back mean?
I knew you were gonna ask me that. Total back command. Hold on, I don't remember.
There we go.
I should have said Python turtle back. Python. After I typed that, I went there anyway.
Mine's supposed to, oh, okay. I was like, it just kept going.
Back. I think it means go back where you came from. It says move the turtle backwards by distance. In other words, so if it went head 20, it's going to go back 20.
Okay.
So that way I could go back to where it kind of started from.
Okay.
Not totally, but. So,
Oh, that makes sense.
everybody got this?
Yeah. How do I move it down? Make the, oh, never
Y'all got that?
Yeah.
And I'm not going to walk through the code for it. Because, I mean, we got the code. The code's not long. But you can just see how. Can you imagine writing that without recursion?
No.
Exactly. So, does someone got a problem?
Yeah, it's not. Just one circle, so it's not even.
Let me get my code up here.
I don't know how it works, but how do I do that? Probably not. It's like math.
You put left twice.
It's like,
Oh, no, it's at the
go
indent.
with math. You go, why do you do that? And he goes,
Yes.
you just do.
Just do. Oh,
Just
just
It'll have to
do.
be part of that. Or all part of the
This is
branch.
the other.
It could be left.
Oh, it could be L.
It could be LT. So yeah, all this code we just wrote has to be underneath the branch function. Okay? The code down here doesn't have to be, but that's
Take screenshot.
so far so good.
I can make a shortcut. And I do that. Add shortcut.
All right. We all there?
I'm not gonna remember that. Shift command. What's
That's all we added.
command S? I can remember that.
This is wrong. I thought this is very wrong. Oh no, words wrong.
It's good, mine was going along too.
Hold on.
Making it reverse so that it kind of makes like a snowflake design.
That's,
Oh, and then it pops up.
Oh.
Took a screenshot of the entire screen quick outside
Wow.
the
Let's
window.
do that. I just like
click the X in the corner, kill it.
do the same code but make it later.
Wait, is this the, that's creepy.
I just wild. Mine just saves to my desktop.
How do I
You
get,
got the 20. Less than
Don't
20
save.
return.
well, when I do like,
Forward,
most of the
yeah.
time it does, it saves to the desktop.
Is this supposed to be
When I do,
It doesn't matter.
I
Yeah, it's supposed to be
didn't
indented.
even have the option, so I had missing it.
That's right.
So I had this little thing, right, and I could take.
can you not do shift command 4?
I probably can, but I just.
Should be 300, 600, 300.
I always forget how to do everything.
Or do I have one too many? I just had that little shortcut.
I don't think I realized that.
Yeah, you look like you might have one too many.
What?
Yeah, you do.
No, I missed. I don't think I realized it did that. I knew it did this. Now I can't remember how to do it.
Yeah.
And then pull down, where's pull down? why is it not
You do
coming
it
down?
with your fingers.
Yep. Stop it.
Push it.
That's an X sketch.
And then you do it like.
So you got left 300, looks like you barely read your, no, you got forward. You got forward first, don't you? Forward in, you got that, then left 300.
I never remember the shortcut, so it doesn't matter. I have this little game over here.
No, it's LT, not
Have
LA.
I ever played it? Probably not.
Technology.
I still love these games.
I hate those games.
Looks kind of like a heart almost.
Is it
So it's
gonna
left
let me
300,
play or is
then
it gonna
branch.
solve it for me?
That's 20.
Dear God.
Then right, you got two lefts.
I don't remember what the
Right.
picture looked like.
And the next one's
That's a
left.
hard one. It's just a freaking rock.
Yes, he does. There you go. Alright. Alright. So everybody got this? Yes? All the way in the back? Man, we lost like a lot of class today, by the way. Okay, let's change it a little bit. I have not done this. But let's change this to 150. See what it does.
Don't do 200.
You gonna be here a while?
I got part of it solved. I
Wow.
gotta go back.
200 will be all over the place. It's going everywhere.
It draws like a giant Hubert map and then it moves up into the upper corner and keeps going.
Look at that thing. Yeah, that 150 is too much. All right, yeah, definitely don't go. We started with 100. Let's go with let's just do 50.
I know, I just realized that was a different one.
Well, that sucked.
That looks so cool.
Chicken feed.
How about 70? I think it has to kind of divisible by 20 to make it look right. There you go. Sounds better. Charlie Brown tree.
What is this?
So is this the hard one?
So yeah, 100 is what we want here.
1,000.
Okay, you want him to make it do something even weirder? Okay, let's add a little bit more to it. Right down here. This is outside the indented part, okay? Type T dot left 120 branch 100 then T dot left 120.
Oh, is it gonna draw a little circle?
No, not yet. Okay. I'll minimize that one. Oh man, did I miss one?
Dimensional.
Oh, I missed part of it. Hold on. Oh, yeah, there's one more. There's a branch 100 at the end. I missed a branch 100 at the end. Looks like we missed one. Okay.
Yours is so cool. This takes too long.
Isn't it awesome though? Yeah, it's kind of like a snowflake now. Yeah.
Snowflakes with cream.
So if you think about it, that first branch right here we did this top tree. Then this next T left with the 120 down here did this left bottom tree. Then this last one did the right bottom tree. See that?
Is that how we're gonna do the circles?
Not really. Okay, so let's do one more thing while we're in here. Okay, I'm going to remove that last part because it's not really a tree. So I'm going to delete this so we just have the tree. But then I'm going to comment that out just so it doesn't draw the tree right now. Okay? And I'll provide this to you, but you're all going to submit your own. So I know you did it. Now we're going to make a spiral. Okay? We want to stop our spiral. So how about n is less than 5. That's all I'm going to put there for the moment. Okay. Move up the top so y'all can see it. So that's all I got for the moment. So when I run this thing, I really shouldn't get much of anything at all. I literally get nothing. Okay? Y'all got that?
Oh, that's what I messed up. I don't like this.
Maybe my indent too big.
Oh, that doesn't fix it. I don't know.
Y'all got this? This? All I did was put that. I commented everything else out. So. Yes? That side? This side up front? Okay. Alright. So now, let's tell them to go forward. Forward. Let's go forward for N. Do you guys like the word forward or FD?
FD.
FD is so much shorter. As long as you realize that's forward.
Yeah.
Okay. Don't cheat and run this. So, at the moment, he's going to go forward. Actually, I think he's facing this way at the point. So he's going to go forward. Then he's going to go forward for 50. Then he's going to go 45 degrees and stop. Sound right?
Sounds about right.
Okay, let's see if that's what he does.
I think so. Yeah.
Yeah, he went forward, then he kind of angled up. Okay. Now, it's not enough. It's now what's called spiral. Let's just call it with N. See what that does. This is not correct. I just want to see what it does. Because what will happen is go forward for 50, turn 45 degrees. Go forward for 50, turn 45 degrees. Go forward for 50, turn 45 degrees. So he's going to be doing some weird stuff here.
Yeah.
Okay.
I'll have to go on.
There's
I think they go fast. Don't watch out for that. It keeps going.
We're going to wait for him. When's it going to stop? Anybody?
Never.
We did it.
Oh, he'll stop. Sooner or later, we will have a power failure. We're in Oklahoma. It's never going to stop. It's going to go forever.
Don't decrease it.
Because we were not decreasing him. We told him to stop when he was less than 5, but we never decreased it. What if we pass it? Let's just try -1, just to see what he does.
Hey.
They're gonna let girls into the Boy Scouts. What?
They have to. They have to be equal friendly
Oh,
nowadays.
the Girl
Stupid.
Scouts aren't happy.
Yeah. So, everybody got that so far?
Girl into the Boy Scouts.
Can you go back to your phone?
Oh, so it keeps going small. Makes a little circle.
Okay. So far, so good?
Yeah. I like it.
We're not done. How are we doing over here? Sarah, you close?
Yeah.
Summer, you good? What if we do times 0.99?
I don't know.
Now run it.
Can you get bigger? Oh.
See, it keeps calling itself, passing it, n minus 0.01.
Yours looks like it's changing colors.
It's not just getting so close together.
Why am I suddenly seeing the umbrella logo in it?
Okay?
I'm not the only one that sees
Can I move my speed along just a minute?
Okay. So everybody got that?
Yeah.
What if we remove the if statement? What I did was I took out my if statement. Actually, no, I'm going to stop mine real quick because it'll take too long. I'm going to turn my speed up. I'm going to go up here and uncomment out that speed is 0 right there. so he goes faster, or else we're going to be here a while. I'll show you what I did. What's he doing now? Is it ever going to stop?
No, I don't think so.
No, because each time it's passing n times 0.99, so it's getting smaller and smaller and smaller. Sooner or later, it is literally, it's just going to go forever because it's not going to stop.
Mine stopped too.
How do you know?
Because I see the arrow code.
Oh, it arrowed out?
Yeah. Raccoon City, better watch out.
Oh, yes, it's too small. It says, I can't go that so far deep. Okay. Is yours working?
Yeah, but it stopped, but it didn't error out. I don't know why. It just.
Oh, you didn't comment these things out.
Oh, I didn't.
Yeah, I commented out the other day.
What's the fastest speed it can go?
I think 0 is the fastest speed, isn't it? I'm not. They recently changed, I heard, that now Python has better speed control. So if I put it back the way it was, now it's going to go to 5 and stop. Okay. All right, we're making progress. So now I'm going to comment out spiral because we're done with spiral. And I'm not deleting these because I want you all to be able to use your code. Now we got to draw a circle. This has nothing to do with recursion.
Mine is like still going.
Okay, let's define. Actually, let's define a circle. So if we're using a circle, what do you think we might need to know?
Radius,
What else?
circumference.
How about x, y? Where to put it? I guess we could just put it in the middle of the screen. So we're going to use x, y to put it somewhere. Then the radius. How about the color? That's what our circle is going to take. Okay? All right. Then we're going to go shift x equals 40. Shift y equals 30. X equals x minus shift. This is going to be a lot of code, sorry. I spelt that wrong. I can't type minus. There are an easier way to write a circle, but don't worry about that. We'll see that in a minute. We're almost done, really. Is there anyone even close to what I'm typing?
Yeah.
Good.
Yeah, I know I'm waiting.
I have no idea how many typos I just made.
Wait, on the begin full, do we need an underscore instead of dot? Because on that,
And you did full instead.
yeah, begin full.
Do we need that? Yeah.
I think that's an underscore. That's a fill. Good catch. Okay, now don't run it yet. Well, actually you can't because I didn't tell you what to put in here. Is it going to work or not? Pretending there's no typos.
I don't know what this does.
gonna draw a circle. That's not gonna work because we haven't defined relocate at this point. You don't necessarily need relocate, but you will for your homework assignment. So I'm gonna go right above this and I'm gonna add relocate. Because you'll notice down here we called relocate right here.
Yeah.
So now we need to tell it where to relocate. Oops. Remember pen up? So we're lifting our pen up. Set X to X.
Oh, okay.
You know this part. 90 degrees. Alright. It just aims them which way you want them to go.
Oh, okay.
I don't know if it's going to work. We're going to try it. We hope. It worked. Everybody get a circle?
No, not yet. I did
Yep.
something wrong.
Nice.
And
Should like a big green circle.
and down.
Go down in your colors.
Can?
Like after info, you put circle on the very
After where?
I hate how something that little can mess up the whole thing.
So how many people got a green circle?
Have a green circle?
Three of us? You got a green circle? Four? Wow, we're gaining. We're getting fast. What if I want a blue circle?
Type in blue.
If you want a pale violet red.
Red circle, yeah, that's what color my circle is.
Pale violet. You could have a chartreuse 3, by the way. How do you spell chartreuse?
No.
Not like that.
Find out. Not like that.
Hey Siri, how do you spell chartreuse?
Siri hates me, I
Chartreuse. Come on, Google knows everything. It's a liquor? A color chartreuse. There it is. Color chartreuse. So now we're going to go over here. We're going to add it to my Python code. 3. Yeah, look at that one, huh?
I actually kind of like that color.
Mine's not working.
It looks like the vomit
Yeah.
emoji where you
Right.
Go back here first.
And either me or
Pale violet red is my color.
What?
Pale violet red is my color.
Yes. I stolen it, I'm sorry. Actually, I could do aquamarine.
I need to make like a Halloween
what else
like color scheme.
this.
You know that one that I did that was all neutral?
Oh, yeah, that was a
Where are
nice
you actually
one.
calling it? Where's the very bottom?
I gotta give
Don't
myself props
indent
for that.
Unindent that. Not right.
Aquamarine up on the show.
Look how creepy he looks. So gross looking.
What's after that?
Nothing.
Sharp.
Yeah.
Hit enter.
That's one of those things.
Move that one all the way over.
What?
See how circle's not all the way over? There, now go.
Okay.
So how
Got a colon after it? Oh, this define needs to be all the way over.
Oh.
I gotta figure out what this does.
No, those, yeah, I'll grab one.
Yeah. How to
So,
What's done?
now, actually, let's let Summer get hers down there.
It's cold.
Well, I'm just trying to move all these.
Yeah, it's what, 64 degrees outside.
In my English class, they keep the room like 66 and got the little email, little thing in the box. And the teacher apparently said she called like multiple times and they haven't done nothing. So we just sit there and go,
We're just there for these.
yeah, all the time. Every day she's going outside. In between her classes, I'll be walking and she'll be standing outside in the heat.
Yep, got it.
It's cold and I'm not ready for winter in there.
Oh, I love wintertime. I can't wait to plow
No,
snow.
I love winter, but like my classroom's 66 degrees. I'm not ready for it to get cold outside and it's gonna be colder in the
I have a
classroom.
snowplow. I actually plow my street in my driveway. I plow the whole road.
It's not like it snows that much in Oklahoma. Hey, sometimes
I know.
it does.
Not from Connecticut though.
You know what?
See,
I got a hydraulic plow, everything. Right when it snows, I am out. Okay. Everybody over here got a circle drawn?
yeah, I wanna move back to Utah.
He's telling me Utah?
I was born in
You guys have
Utah.
circles over here?
Heck, I have
Everybody got a
never been
circle?
anywhere else.
My dad was in the Air Force.
My other Air Force too.
Experimenting with colors, I thought.
See,
Okay,
like, I was born there and then my grandpa died and my dad got out, so like, we only lived.
So, let's talk about this.
I lived like in Utah.
We now have a circle
Until I was 4.
function.
We moved here.
Hey.
I remember it.
We now have a circle function. And what is 55?
X,
What's 65?
Y,
What's 15?
radius.
The most beautiful color. No, it's good. But could you change where this circle is drawn?
Yeah.
So could I draw another one? Let's draw two of them. I want a circle. So X is that way. What if I did negative 55 and negative 65? This time I want a radius of 25. And then this time I want to just chartreuse 7. Is there, if there's even such a color? There's not. Okay, we cannot have chartreuse 7. Darn it. Let's try chartreuse 1.
Bad color stream.
Oh, but this is not,
Where did it draw?
it's not on our screen.
Oh, mine's there. It's underneath it. Kind of, I think. Isn't it kind of, doesn't look yellow, kind of-ish? Hold
No,
on.
mine's not there.
Mine is like way at the bottom.
This isn't.
Okay, let me lower these numbers. How about minus 5 and minus 6? Oh, there it is. It's way over there. There it be.
There.
So,
There it is.
now I want you all to think.
It's like the sun and earth.
We've written something that drew branches. Okay. We've written something that made a spiral. Now we've written a circle. Do you think we could draw a circle? Now how many degrees are in a circle?
360.
360. So could we divide it by a number and go to a position, maybe 360 divided, like 30 degrees or something, draw a circle. And then 30 more degrees, draw another circle. 30 more degrees, draw another circle. See what I'm saying?
Turn.
No, I mean, that way you're drawing circles around the perimeter of the original circle.
Combine branch with circle.
Kind of. And remember when we did the random colors of our bar graph?
Yeah.
Could we make our circles random colors? Yes?
Yeah.
Okay. All right. So if we had a circle and we drew circles at positions around that circle, could we also draw circles around the positions of the smaller circles? So we got the big circle, then the smaller circles, and each of the smaller circles has smaller circles around them. See what I mean?
Yeah.
Can we do that?
Is that our
Can you
homework?
just
That's our
have
homework,
branch
isn't it?
called
So obviously we can do
called
it.
spiral, and then have spiral called circle?
You don't really need spiral, but you think of it, spiral stopped at a certain position. So did branch. Remember, branch stopped when the list distance got to be whatever. So you can continue to draw circles, maybe passing a different radius. And once radius gets to a certain point, then no more circles. You know what I mean? See what I mean? I have not written all this yet. I've literally designed it 10 minutes before class. I will have it done. I will show you what it looks like, and I will probably next class period give you a little bit more insight on it. But once you get these methods, I mean, heck, we got circle already written. We should be able to call. We should have a, draw recursive circle function that can literally call itself to keep drawing a circle until it's gone all the way around. You know what I mean? And then if you do that, then yeah. Start thinking it and playing with it. Okay? I realize this is a beginning programming course, but at least you should have some idea. Okay? So I can plan. It's not due for 2 weeks. And depending on how difficult it ends up being, because I'll try to write it all today. I will let you, I might move the date a little bit, okay? But you should get an idea of at least recursion at this point. Okay. Everybody okay on what we got here?
Yeah.
Okay, submit your actual Python code so I know you wrote it. And I'm going to submit my code in today's folder. And if I see my exact code in there, we're going to have an issue. In other words, don't just download my code, change the name, and submit it.
Oh, I have my
Okay.
It's in recursion, right?
Yeah, add it.
No, that's.
Yeah, add it in the recursion one. It's like we missed a letter, so it's like what, L or something? Yeah. Okay. So start date is today at 2 o'clock. Update. You guys should no longer be able to see today's stuff, but you will at 2 o'clock.
This is my personal finance.
What did I call this darn thing?
And then she
October
goes,
11th.
if you guys didn't
Oh,
get
there
the
it is.
grades you expected, she was like, don't feel bad, that's what she was like, I expected your grades to be.
Yeah, I'll explain what I just said in 1 second.
It's easier. I think she will.
Okay, I just hid today's folder. Okay? That way you can't just download my code and upload it to your own thing.
Until after our things due.
At 2 o'clock, you'll be able to see this code. Then you can download my code.
Okay, well, and she like, why are you on other things?
Ooh,
Okay?
what is that?
What?
That better not be a wasp.
All right. So remember, we commented out all the stuff to draw the branch. We commented out this everything else. Where is he?
He's
up
up
on
there,
fire.
and I don't like wasps,
I'm
cause
gonna
one time I
call
was
him
just
right now.
laying in bed and a wasp stung me, I wasn't doing anything.
How did it get in your house?
That's my question, I thought I had some weird nerves,
Do you
I
want
was
us to
like, what
comment
is
all that
that?
stuff
And I
or
was
just
What?
leave it as is?
You can just upload it as this. Who's this? I didn't mean to call you, but okay. Well, transfer me to Stephanie real quick. So, unless you want to come up and kill this wasp. Yes. Just tell her there's a wasp in 203. We need it killed.
So you send a girl to do
It's in
it?
203. There's a wasp in 203. Bye.
Yeah, ice water, that's what you need.
Yeah. I paid them. I'm pretty sure all you girls have them knapsacks you carry around. Just
We're not doing one.
same thing. Where is he now?
right there.
Come on up here. Come on up here. Get up here. Oh, literally, he's literally right.
It's on your bed.
He's gone. He's gone. Okay?
Yeah.
dead.
It's a pretty good thing for my head.
Yeah, exactly. The lid is literally right on your head.
Okay, what's funny? I want to know.
We killed him. There was a wasp in here.
Oh, you killed Waspy?
Yeah, on my head.
He's literally laying on her head.
He's my best friend.
Yeah, I just called downstairs, told him to come kill it, but Sarah attracted him. So yes, he's now dead.
It's the flowery red hair. That's what it is.
Yeah. Well, no, I had my hood
Luckily,
up
she
and
put
then-
her hood up. It literally landed right on her hood. All right, so there you go.
So did you make a Python program that does recursive circles?
No, we drew the circle and did the other ones. I knew we wouldn't have
I have
time. Class is
one.
over.
I just made one.
You wanna slide that our way?
Hold on. I'm gonna
Let me
say-
stop recording.
What is it?